Hi there. Welcome to this lesson on Further Pure Mathematics 2. And in this lesson, we're looking at how you multiply and divide complex numbers when they're written in exponential form. Now, in a previous lesson, we learned the following results for the modulus and argument of any two complex numbers, z1 and z2. First of all, if you have the modulus of two complex numbers multiplied together, you get the same answer as if you had the modulus of the first complex number times by the modulus of the second complex number. If you have the argument of two complex numbers multiplied together, it's the same as having the argument of the first one plus the argument of the second one. And then you get similar results for division. So the argument of one complex number divided by another is the same as the argument of one divided by the argument of the other. And the argument of one complex number divided by another is the argument of one take away the argument of the other. Now, if z1 is equal to r1 times e to the I theta 1 and z2 is equal to r2 e to the I theta 2, using the above results, we can obtain this for multiplication, that z1 times by z2 will equal r1 times by r2, and then e to the power of I, and you add the arguments, theta 1 plus theta 2. That's using the first two results at the top. Now, I think you could just get that result using the normal index laws. You'll want to be careful about using the index laws when you're dealing with complex numbers, but certainly in this instance, I don't think there is any issue. So you could just multiply z1 by z2 in the normal way. And z1 divided by z2, again, either using the normal index laws or using the results we got up above, you get z1 divided by z2 is equal to r1 divided by r2 times e to the power of I, and then the difference between the two arguments, theta 1 take away theta 2. Okay, we'll have a look at an example. Express 5e to the pi by 4i times by root 3e to the pi by 12i in the standard Cartesian form, z equals x plus iy. I'll let you have a go at this example yourself first. So pause the video and then come back to me again when you're ready. Okay, let's have a look at this. So that's the result we'll be using, that if you're going to multiply two complex numbers together, it is much, much easier if they are in the exponential form, either multiplying or dividing. If the numbers are in exponential form, the process is very straightforward. So if they aren't in exponential form, really, I probably would advise just convert them to exponential form first, then do the multiplication or the division. So in this case, for the moduluses, we'll get 5 times pi root 3, which is 5 root 3. And for the arguments, we'll get pi by 4 plus pi by 12, which is pi by 3. So that's the answer in exponential form. The modulus, as we said, is 5 root 3, and the argument is pi by 3. And we can use that to now write the complex number in modulus argument form. So z equals r cos theta plus I sine theta will be z equals 5 root 3 into cos pi by 3 plus I sine pi by 3. Pi by 3, 60 degrees. The cosine of 60 degrees is a half. The sine of 60 degrees is root 3 over 2. So we can calculate those and put those in. And then multiplying by the 5 root 3 gives us the answer in the form they've asked for. So z equals 5 root 3 over 2 plus 15 over 2 times by I. Second example, we're asked to express that large expression there in the form z equals r e to the I theta, so in exponential form. And I've started the question off just because it's so easy to miss this. The complex number on the bottom of the fraction is not written in the standard modulus argument form because there is a minus in the middle. There has to be a plus. So that's the first thing you need to resolve. But I'll let you have a go at this yourself first. So pause the video again, have a go by yourself, come back to me when you're ready. Okay, so as I said, This minus does need to be sorted so that the complex number is written in the standard modulus argument form, which has to have a plus in the middle. The method for doing that is always the same. You just change the angle. You change the sign from plus to minus or minus to plus, whichever way round is needed. So in this case, we'll change the angle to plus 5 pi by 6. For cosine, that's not a problem because the cosine of theta and the cosine of minus theta are the same as each other. But for sine, we'll need to change the sign here because the sine of minus theta is equal to minus the sine of plus theta. So that will give us cos 5 pi by 6 plus I sine 5 pi by 6. Then we can rewrite the question. So that is what it says now, exactly the same as before, but we've changed the angle to plus 5 pi by 6 and we've changed this minus to plus down here. And then we can change that immediately to exponential form. So the top one, the modulus is 2, and the argument is pi by 12. We can just write it down straight away. And on the bottom of the fraction, the modulus is root 2, and the argument is 5 pi by 6. Having done that, we'll then use the rule that we found at the beginning of this lesson, that if you're going to divide one complex by a number by another, then it is easy as long as the numbers are in exponential form. You divide the two moduluses, so we'll get 2 divided by root 2, and we subtract the two arguments. So we'll get pi by 12, take away 5 pi by 6. Pi by 12, take away 5 pi by 6, gives us minus 3 pi by 4. So that's the answer in the form they've asked for. Root 2 e to the power of minus 3 pi by 4 times by I. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 28 and have a go at exercise 3b. Thank you very much for listening, and cheerio.